Hey guys, it's Vince. Today in this video I want to discuss a couple topics. The first topic I want to discuss is one that I'm really excited about. Um, I have been privileged and blessed enough to work with one of the largest corporations in the world. I was selected the same way that most of you select me now, and that's from YouTube, believe it or not. An engineer contacted me about my YouTube channel, and I guess they were reviewing videos for their project and they liked what they saw. We set up a phone consultation, we discussed their project, and I started consulting with them, and eventually they purchased a system from me that I built for them. You can see that this is my PayPal account. You can see here that I have my Microsoft Word documents open, 1, 2, and 3 of them. And again, they're strategically placed on the page so that I don't disclose any of their personal information. But the information that needs to be disclosed is, first of all, I did receive a payment from them, which you can see right here, net amount and fee amount. And then you can also see over here their email. Okay, and this is not their complete email, but you will see the company in which I'm talking about. And you can see boa@boeing.com. Now, everybody out there knows who Boeing is. I want to make a clear point, and I think with my channel I've been trying to do that. I try to keep the BS to a minimum. I want you guys to learn something. I wanted to make it really insightful, that this is an open channel. I don't care what your knowledge base is on CNC. If you're interested, I'm hoping to gravitate towards educating rather than, this is not a beat down channel. Whether you have different ideas, I'm fine with that. But this is, if you have your own ideas as far as what you think is relative, start your own channel. Don't beat down someone else, start your own channel. But for all the beaters out there that like to post things and say that, one thing is done wrong or one thing is done right, I just built a controller for Boeing. Okay, I work with 4 of the top engineers in the country for a project that may require 1 to 200 of my systems. Okay, the same systems that I offer to you, the same YouTube channel that you guys review, they reviewed. I feel that the company I keep is a defining factor of me and the presence that I offer you. So ultimately, if you look at right now, just knowing that Boeing chose a system that I offer to you, meaning a Gecko G540, 3 600-ounce steppers, 2.2K spindle, 2.2K VFD, spindle cable, it's all the same components that I offer to you guys, okay? And believe me, their project is pretty extreme. I mean, it's a very, very, it could be a costly project, let's put it that way. There is nothing cheap about dealing with aircraft parts, okay? That being said, if you've been on the wall about what components to use, what drivers to use, do you need servo or stepper, really think about that. Because if Boeing can choose a stepper motor, I feel 98, 99% of you are going to be fine with a stepper motor. If Boeing can choose a G540, 98, 99% of you will be most likely okay with a G540. Overall, it shows where technology has gone. And everything I've discussed about small business for you or your hobby, and again, I hear the word hobby being used a lot, and I really truly feel that I hope you guys get past the hobby use. I hope that you eventually look at your hobby potentially becoming a business that you love, that you're not dreading going 9 to 5, driving in 2 hours of traffic, and then you come home, you're hit with massive amounts of tax, you're bringing home a quarter of what you used to bring home, and times are different, guys. Technology is changing every day. These companies know that. The same companies that employ mass amounts of people are realizing I can cut my overhead down by using micromanufacturing, and that's exactly what they're doing. I don't need to tell you how big Boeing is. It's not a resource issue. They could have anyone they want work for them. That's why I'm so flattered. I mean, let's be real. Boeing calls you up, you kind of pick up the phone. Think about that for a minute. Think about where you are, what you want for your project, for your business, for your hobby, whatever it may be. Think about the potential of owning a micro manufacturing robot. It's amazing. And I mean, we're not talking a robot that only deals with plastic or only deals with wood or only deals with metal. Virtually anything. You can automate anything with robotic precision, pending you take the time and understand what you're doing and where it's going. I mean, it's virtually unlimited. So when you're defining what you want to do with this project, whether you're interested in it, maybe this is just the first video you found, I cannot say enough what this really defines when you think a company like Boeing is buying a Gecko G540 system. That really tells you where we are, and hopefully it defines what you need for your application or where you want to go, and it really defines the price. Look at the price point here. We paid $1587. I mean, guys, that's ridiculous. Haas mills are $30,000-$40,000. Most guys are never going to require that ever in their life. Most corporations I know don't usually require it. They don't usually run them full time unless it's, full scale manufacturing at an extreme level. Think about that. If you have a project, if you have an idea, if you've had a design in your head, a lot of guys are brilliant engineers and don't even know it. You don't need a degree for that. It can sometimes just be instilled. You go online, you get ideas, and then you have to wonder about how can I implement it. Let me tell you what, it's amazing when you think you can own the equipment, teach yourself the software in whatever amount of time you have to invest, and the next thing you know, you're producing your own components. You have literally become China, except we have US standards, which will dominate. If you really think about it, it will dominate. And that's why I'm exceeding in my business, and I also know that's where the future is going. I can tell you that right now. Most of you who are subscribed to this channel know exactly what I'm saying to be true. So overall, like I said, I'm blessed, I'm honored. To me, I've won an Oscar. To work with them is amazing, and it also defines that I'm doing it right. I know by that I'm doing it right. I'm trying to give you guys the information that's accurate and give you guys, a place to sit here and learn and watch, and that's really what I want. So thank you to everybody at Boeing, of course, my engineer friends, and again, thank you guys for subscribing or even just watching, trying to learn something. I think it's great. I think that's what YouTube's about. That's what social media should be about. It's not about trolling. It's not about negativity. It's about sitting back, trying to acquire as much knowledge as possible without having to pay, again, a government institution, hundreds of thousands of dollars to learn. You guys have this potential now. It's amazing. So the other part of this video I want to cover, again, is something that I've been thinking about. And I want guys to really understand the gravity of CNC. And so I came up with, again, I do graphics as well, and I wanted to talk about the CNC chain of stability, okay? And you can see we have a chain here, and this is just like corporations use, guys, okay? Just, fishbone theory, Six Sigma, all that neat stuff. You got computer, software, controller, chassis, calibration, and troubleshooting. When guys tell me that they buy a chassis, or they buy motors, or they buy my controller, and they're assembling other components, I want everybody to be on the same page as far as what is required to have a CNC robot that is stable, okay? And this is why it's so difficult to really fathom what is required to have a robot that's stable, okay? Let's think for a minute. CNC, computer numerically controlled. That's what CNC stands for, okay? If you think C, the first C is computer. A lot of guys never even fathom in what computer they're going to use with their system. They do after the point. I'm going to use a 1993 Dell, whatever, dinosaur. Okay. And then you're going to use software that hopefully you understand. Hopefully in the sense that if you purchase Mach 3, you see CNC, whatever you decide to use, Linux, whatever that may be for motion control, you understand it enough that you can set your machine up properly. Then the software then feeds that information over to your controller. Okay, you can see how important these links are over to your controller, and then of course if this information from the software is input incorrectly, it feeds that incorrect information into the controller, which of course the controller and stepper motors or whichever type of motion control you use, whether it be stepper, servo, it then feeds that information into your chassis. So let's look at something real quick. If any of information is lost between these four links, guess what? You're done. You're inaccurate. You're troubleshooting, okay? And then you can see I put troubleshooting at the end. And the main reason I put troubleshooting at the end, because it really applies to every single link in this chain. Computer troubleshooting, software troubleshooting, controller, so on and so forth. I want you guys to understand what you're getting involved with. And why I say that is when I hear guys call me, and they'll say to me, I'm having trouble installing software. Let me ask you something. There's not a piece of software on the market that is not free to test when it comes to CNC. You can download a demo of virtually every program that's out there. The first concept that you should think of when you're looking at getting involved in CNC is the software. I've said this in numerous videos. I want you guys to realize that between the computer you're going to use and the software you're going to use, that will essentially run your machine. The old cliche of the old woodshop mentality where I'm going to go out there and work on my jigsaw or my sander or whatever, it's over. That's done. There is no more woodshop. It's CNC. This is where the future is going. That means if you're not a computer guru, if you don't understand Windows and you can't work with, software installation, odds are you're going to have trouble with CNC. Why? Well, we know that computer is the first word or first abbreviation in CNC. So let's think about that. Okay? Let's really think about where you stand in all of this. Once you get past the software and configuring the software and understanding the software, you should be reading all of the manuals, all the documentation. Pretend the internet does not exist, okay? At least for the first month. And pretend that all you have is the software documentation and bury your head in that book and learn it. Learn it, play with it. Sit there, go back and forth, back and forth, back and forth, and eventually it will digest. But if you don't put that time and effort in, you're never going to learn. You're never going to be able to get to the level that you're acquiring. And that means in everything. Because again, as far as you come here, you can see I put chassis here, and then I'm talking about the actual chassis itself, the CNC chassis, which is your metal substrate frame is what I'm hoping for, the robot. You're going to get then the calibration. Okay? And once again, if by the time you get to calibration, any of this at all is off, any of these other links is off, the entire chain collapses. That's what I want you guys to understand. Visualize this chain in your mind and visualize that if one link is wrong, it's all wrong. There is no such thing that what you're actually getting, all I need to do is buy a chassis. All I need to do is buy the controller and I have a CNC. It does not work that way. You have components until you've assembled every single unit and made sure every single part and component that's listed in this chain is set, minus of course the troubleshooting, which I guarantee you at one point or another will come in for probably every single part of this chain. If that's not something you can digest and fathom and really think about in the sense of, am I a guy that likes to work on the computer? Am I a guy that likes to work with software? Am I somebody who wants to get involved with a challenge every time I turn the machine on? This is probably not going to be something for you. Okay? It can be the most rewarding or the most frustrating endeavor you've ever tried to get involved with, mainly because of everything you see here. Because there is not one piece that's most important. All of them synergistically make for a perfect chain of stability. And that's why I want you guys to really understand that. It's not about saying, oh, well, I'm great with software, but I don't know what the hell I'm doing with the chassis. I don't know how to set it up. I don't know how to build. You guys become a master of everything. Everything. Where companies have technicians who work on specific components, you have to digest everything. It's a different mentality. It's a different type of learning. It's not for everybody. But for those who take on the endeavor and those who really think about what they want to achieve and where they're going, let me tell you what, I look at it this way. If I find something interesting, I will do whatever it takes to learn it because I find it interesting. That's who I am. That doesn't mean that's the way it is for everybody. I believe details are everything, and that's the thing that's always interested me about engineering is because details are everything. The thing about CNC is it's all details. There is not anything that's not about details. When you go to assemble your chassis, you should be torquing and actually going through and using Loctite on all the bolts. That should be done. It shouldn't be discussed. It should just be done. Everybody is different in their mentality as far as how they assemble. It doesn't change the fact of what should be done. It just changes the fact of the way you think it should be done. So philosophy plays a huge role, but I want guys to understand when they're dropping their money or where they're looking at dropping their money, what they're going to really take on it as a role. Because all of this, when you pay for your computer, pay for the software, the controller, and the chassis, just right here with these four components, in excess of $3,000 to $5,000, no problem. And that's again with a realistic price. Okay, I've done videos on all the components required to build a CNC. I want you guys to understand what that really means. Okay, all the components required to build a CNC. What I didn't include in that video is all the knowledge that's required to build and run the CNC. And this is what you need to know. You know, if you get to a point, and every guy does, where I'm having software configuration issues, then you're back to troubleshooting. Well, I got the software configuration issues figured out, and then I'm going in my controller and I'm setting everything up there. I'm doing calibration. I move over to calibration. Now I'm troubleshooting again because something isn't calibrated correctly. This is the kind of rhetoric you'll be dealing with on a routine basis. This is not going to go away. The more adept you become with it, the more familiar you get the feel of your machine, then it becomes eliminated, basically. Because you know by feel, okay, this is right. I'm good here. I'm good there. You know, it's all steps. It's baby steps. You know, this is a big ass elephant you're trying to eat. So you got to stay realistic with what you're trying to do. And that's the thing. If you're a novice, like I said, bury your head in the software, in documentation. If it's manufacturer produced documentation, it's going to be accurate. Don't sit there and focus on forums. You don't know who you're learning from. You don't understand that people will post just to post. People like to, you know, feel smart. I got to say the truth. I mean, everybody will want to show you what they know and what they do, and they might genuinely mean well, but odds are there's a lot of interpretational problems that come with that when you get opinions. You know, when you get, hey, this guy's using this guy's using that. I have guys ask me about forums all the time. Well, this person's telling me that, you know, this product isn't working well. Well, this product may not be working well because he doesn't understand it. You know, everybody's knowledge base is different. You know, it is what it is. I have guys dealing with Arduino boards, moving up to, you know, full CNC machines. Oh, I want Gecko Pro drives. And, you know, going from Arduino to a Gecko Pro drive is like, you know, going from a go-kart to a Corvette. It is what it is. You know, let's be real. And that's what I want you guys to realize. I want you guys to really understand, to get your machine into a chain of stability, this is what is required. You will make sure that your computer is perfect for what application you're using it for, which again is motion control. And then you're going to move on to your software, which is going to be motion control software on top of the actual CAD CAM software, which again, guys, learning those two pieces of software can definitely exceed months easily. I would say probably a good solid year, between 6 months to a year. If you have more than 2 to 3 hours a day to spend and really digest the information, you're a quick learner, you're hands-on, I would say, in all honesty, 6 months to a year, you're rocking and rolling. I mean, don't get me wrong. Within 1 to 2 months, if you're doing just general part cutouts and you're doing the same geometry and the same files, you'll pick it up very quick. But once you start doing and you want to get, because you know that's what happens, you start tweaking things and playing with things and you become more meticulous because you see what you can do, and then all of a sudden it's like, well, I'm not happy with this anymore. I want better than that. I want this, I want that. And that's where that intrigue starts backing you up and you start getting more and more in depth. And the next thing you know, you're moving on ahead at, you know, full speed. I want to learn as much as I can learn, and that's brilliant. That's what I'm hoping you guys want to do. You want to learn. You always want to learn. You're never happy. You're never comfortable, and that progresses you forward, not just in life and business and everything else. But again, it takes effort. And when we move from here, and again, once that software is digested, the controller and the chassis is the next thing. The great thing is you can incorporate learning all of this if you're willing to, but you have to do it in steps. You know, when you get your new controller in, if you just bought a controller from me and you get it in, don't mount it right away to your table. Use it off the table. Test everything off the table. Test the software, see what it does. Test everything. You know, run a sample job. Run Roadrunner, you know, just to see it move, just to see your motors move. See how everything corresponds with one another. You know, a lot of it is just seeing how everything works and then thinking about it. You know, take a step back, think about it. You know, if you do have to troubleshoot, which again, it's going to happen, plan on it. Be good at it. Don't plan on sitting there and saying, oh, I'll just message somebody a blatant email. I get emails all the time that are totally incomplete, totally undecisive. I don't know, you know, oh, I'm having trouble with this. Okay, how do I know what you're having trouble with? We have to use logic. We have to use common sense. The more detail you provide me, the more intelligent of a response I can give you. I can't give you a response if I don't know exactly what you're dealing with. The whole idea of this is so that you guys become empowered to control your destiny. And the only way to do that is become self-sufficient and master the machine. And that's truly what you have to do. You have to master all of these to get to the level that will produce that level of stability. And I want you guys, like I said, I wanted to do this because I think visualizing a chain, for me, it really brings that out. It makes me understand, okay, I need to learn all of this. If one link is gone, you're done. That's it. There's nothing else. Hell, even if troubleshooting is gone, you're done. Because if you have a problem with any of this, guess what? If you don't know how to troubleshoot correctly, you certainly can't diagnose anything wrong with any other part of the chain. So think about that. Put together a plan. If you see this, and hopefully you guys find this video before you purchase anything, put this plan together. Say, you know what, tonight I'm gonna think about the computer I'm gonna install my software on. Okay, this looks good. Nice computer. I've got this set up. Boom, done. I'm good. Preferably a computer that only has CAD CAM software, motion control, something dedicated. If not, if it's a laptop or something that isn't, make sure it's clean. Don't have a lot of programs running in the back. Keep her clean. Focus on, this is my production system. Think about it in them terms. Then when you move on to the software, same thing. I'm ready to move on to my software. I'm going to focus on my software. If you don't have the controller, if you don't have your chassis, focus on the software. Learn all the terminology. Dive into the book, like I said. Sit there for hours, read, find it interesting, play with the software. You can do that. You know, the more detail, the more effort you put into becoming a master of each specific part of this chain is what's going to make you have a system that you'll never have to worry about. You'll know and understand, okay, I know my unit, this is it. And you'll carry over into the next system. I have guys that want to build 2 or 3 systems. I have guys running 2 or 3 systems simultaneously. And that's the only way they can do it. You know, I mean, the robot will do only what it's told to do and will produce only what it's told to produce and, again, perform only how it's maintained to perform. So think about that. You know, when you're troubleshooting, write every detail down. Not only write it down, write down what you tried to correct it, the actual pros and cons. You know, go through what change made, date it. I've done a troubleshooting video before. I don't see enough hits on that video. I gotta be honest. I would have thought that video would have produced more hits because it really covers the same documentation we use in full-scale facilities, especially when you're dealing with technicians. Unless the technician knows the machine and that's all that technician works on is that specific machine, they're documenting everything, not just for billing purposes. Because if you're a corporation, you're gonna need to know what actually is going on with the equipment, but also to keep them from chasing their tail, guys. Document everything. You could try something and be like, look, I'm doing the same thing over and over again and nothing is producing a result. I've had guys do everything. Oh, I've tried everything with my system, and then it turns out they misconfigured their motion control software for e-stops. Or, you know, another big thing to think about when it comes to troubleshooting. Anybody will tell you, if you do a search online, you know this, the first topic that comes up is random e-stops, random switches, ghosting in the machine where things happen you're not telling it to. EMI, biggest devil when it comes to electronics. Everything, including your table, should be shielded, guys. Grounded. The table should be grounded, all your motor cables shielded. This is what needs to be done. This is what this endeavor entails. It's not an hour job. It's not a job. If you tell me, hey, I shielded all my cables when you told me 20 minutes ago that they weren't shielded and you properly grounded them and that, I already know you're not right. I already know that's most likely not the case. So think about that. Everything takes time. Do it right. Use this chain of stability and really think about each part of it. And I promise you, you will become more of a master. You can look at this and say, okay, what do I know about my chassis, my controller? How much do I understand about all this? You know, where do I think I'm weak? Think about it. Weakest link, you know that old cliche. Think about that. You can study this and move appropriately to the next level once you feel confident, and then work back. You know, work on a troubleshooting method that works best for you. Everybody's different. I like writing stuff down. I go old school. I write everything down. I write down, you know, I date what actually occurred, and then I can go right from there and say, okay, well, this is what I did to fix this. Does it happen again, or did it, you know, resolve the issue? If it didn't, then I'll write down again, okay, tried this. Remember, half the battle is knowing what didn't work, okay? If you think about like that, everything, if I know this doesn't work, I'm one step ahead. No different than if you know what works, knowing what doesn't work is still one step ahead. Document it so you learn that. Always keep that in mind. The more you write down, the more you learn. So again, watching videos is great. I try to be as informative as possible, and I hope that this video will help you guys. I really do. I hope that, again, the chain of stability, I live by it. I mean, again, without the cool graphic of the chain, I mean, but overall, the whole concept is so true. I mean, there's nothing here, none of these links in this chain can be weak about any of these topics. If anything is weak, you will find it in your system. I promise you. So take the time, think about what I've said, think about the video. And again, if you guys have any questions, my name is Vince. My store is eDealers Direct on eBay. You can message me through YouTube. My email is storm, STORM 2313 @gmail.com. Thank you all. Take care.